Hello, so we need to be able to work with functions and function notation. So firstly, you need to recognise these four set of numbers: natural numbers, which are basically positive integers; the integers, which are just whole numbers; rational numbers, which are basically fractions with integer top and bottom; and R is real numbers, which are basically all real numbers you can sort of think of, right? And another thing you need to look at with these set of numbers is, for example, if we said X is this symbol here, let's say Z, this reads X is an integer, okay? Or more specifically, X is a member of the set of integers, okay? Which means that obviously X is an integer, it's a whole number, so it belongs in that list. And this sort of E symbol means member of. So it's a member of the list of integers, okay? That's what that's saying. So X is a list, is part of the integers. And then back to functions. So if we have, let's say, f of x, y is equal to f of x. So obviously X is my input and Y is my output, is the values I get out the function. And more specifically, the list of inputs is the domain of the function, and the list of outputs is the range, okay? So the domain and range of the function are the inputs and outputs that we get, okay? So you can think of it as x and y's, almost, okay? And then lastly, roots. So roots are of a function of f of x equal to 0. If we solve that equal to 0, then x is a root. If it's a solution to the function set to 0, okay? And that corresponds, a root corresponds to the intersections with the x-axis. So we've got our two roots there and there, for instance, okay? So let's have a look at some examples. So we're given a function f and g, where f of x is 2x minus 10, g of x, x squared minus 9. We need to find f of 5. So we're going to plug in 5, x is 5 into f of x. So that's going to be 2 lots of 5, take away 10. That'd be 10 take away 10, which is 0. And that would mean 5 is a root. But then also g of 10, that's going to be x squared minus 9 when x is 10, so it's 10 squared minus 9, 100 minus 9, which is 91. Then part B, we need to find the value of x when the two functions are equal. So we set them equal, so that means that 2x minus 10 is equal to x squared minus 9. So if I move all that to the other side, I get x squared minus 2x, add 10 minus 9, that's plus 1, equals 0. So we can factorise, for instance. So factors of 1 are 1 and 1, obviously. So then if we want to add them to get minus 2, so our factors are just going to be x minus 1 and x minus 1. Or we could just say x minus 1 squared equals 0. So x equals 1 is my only solution there. We have the roots of this function. We need to find the roots. That's when f of x is set to 0, okay? So x to the 6, add 7x cubed and minus 8 equals 0. This is a disguised quadratic. I could say u is going to be x cubed. So then we get u squared, add 7u, take away 8 equals 0. Then I could solve that by if we can factorise again. So factors of 8 and 1, that's great, because then if I do positive 8 minus 1, that adds to get 7, and times to get minus 8. So then my factors are u add 8, u minus 1 equals 0. So u is equal to minus 8, or u is equal to 1, but we want to solve for x. So then x cubed is equal to minus 8, or x cubed would be 1. So that means if I cube root everything, I get x to be minus 2, or cube root 1 is just 1, so x could be 1. And those are my two roots to the function.